Hello everyone. This video would focus on graphing absolute value equation in vertex form, and this is the third part. In this part, the absolute value of A is greater than 1. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to absolute value equation in vertex form. Before we jump into this example right here, let's have a review on the basics of absolute value equation in vertex form. We remember that the equation for an absolute value equation in graphing form or vertex form is y equals a absolute value of x minus h plus k. Now let's go over the effects of the parameters a, h, and k to the graph of an absolute value equation. We remember that if A is positive, the graph opens upward. Now, if A becomes 0, then the graph becomes a straight horizontal line. On the other hand, if the value of A is negative, the graph of an absolute value graph will open downward. Now, we also remember that this A is called the stretch factor, meaning it makes the graph vertically stretch, which makes it narrower, or it makes the graph horizontally compressed, which makes it wider. We remember that the closer the value of A is to 0, then the graph becomes wider. So if you notice, the graph gets wider. We started from the negative side, and then we go towards the 0. It becomes wider and wider to the point that if it gets to 0, then it becomes a horizontal line. This is also the same thing for the other side. So if we start from 10 right here, we go all the way to 0, then the graph becomes wider and wider up to the point that it becomes so wide that at 0, it becomes a horizontal line. On the contrary, we remember that the farther the value of A is from 0, meaning if we go towards the negative side, then the graph becomes narrower. So as we go farther from 0, it becomes narrower. We remember that the coordinates h, k is the vertex or the locator point of the graph, where our h translates the graph left or right, while the k translates the graph up or down. Okay, going back to the problem right here, we're supposed to sketch this equation, the graph of this equation right here. The first step is to determine the vertex or the locator point. I'm going to go ahead and write it down here. The coordinate of the vertex or the locator point is hk. So this represents our h, this represents our k. To determine the coordinates, we are supposed, again, the trick is to switch the sign of this. So that would be a positive 4 and keep the sign of this. That would be a negative 1. So this is where the vertex is going to sit. The second step is to create and complete the table of values. So I'm going to go ahead and write the table of values down here. Now, we are going to place this locator point in between these blank cells. So we're going to put that in here. So this would be for 4, and this is negative 1. And we complete the values of x in this table. So I can write 5 here and 6, then going down here 3 and 2, so that we can go ahead and determine the values for the rest of these blanks. So we're going to show the work on the side right here. We will start with x is 3. So I'm going to go ahead and write it down here. X is 3. So what we would do is we are going to plug in 3 to the x here so that we can solve for y. And so this equation would come out y equals, that's 2 absolute value of, that's going to be minus 4 minus 1. I'm going to use red in placement for the x, which is 3. And so we do the math here. So this would be 2 times the absolute value of 3 minus 4 is negative 1 minus 1. And then we have 2 negative 1 absolute value would actually be a positive 1. And then that's minus 1. So 2 minus 1 is 1. So this is our value for x is 3. So I'm going to go ahead and write 1 right here. And I'm going to show the work to determine the value of y when x is 5. I'm going to write that on the side here. So what we're going to do next is I will show you the work for x equals 2 and x equals 6 on the side down here. And this is how it's going to look like. By the way, right here is supposed to be 5 minus 4 is supposed to be a positive 1. And we still get the same answer because the absolute value of positive 1 is 1. And so we get 2 minus 1 is 1. And so they're both the same. In here, we have a 2 minus 4 is negative 2. The absolute value of negative 2 is positive 2. So 2 times 2 is 4 minus 1 is 3. And so the same thing for this. 6 minus 4 is positive 2. The absolute value of positive 2 is 2. 2 times 2 is 4. 4 minus 1 is 3. So we can go ahead and write 3 down here. Now the next step is to sketch the graph of this table of values. So we're going to go ahead and sketch or plot this for negative 1 here. So it's going to be on positive 4 and goes negative 1. That's the first dot. 3 goes to positive 1. So this is where it's going to sit. And then 2 goes to 3. So it's going to go up to 3 up here. And then 5 is going to go to 1. And then 6 is going to go to 3. So I'm going to go ahead and sketch the graph here. So this is the graph of this equation that we have right here. Now, please notice that this right tail of the graph is going towards the positive infinity on the x-axis, and this one's going towards the negative infinity on the x-axis. So we can go ahead and say that the domain for this graph would be all real numbers. But for the range, it will start from negative 1 going up. So that would be y is greater than or equal to negative 1. That would be the range. So I'm going to go ahead and write that information down here. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to determine the vertex or the locator point. I'm going to go ahead and write that down here. Vertex or locator point is represented as HK, so this will be our H and this will be our K. To determine the coordinates, the trick is switch the sign of the H, so this would be negative 2, and then keep the K, that would be a positive 8. And so this is our vertex or locator point. The second point is to create and complete the table of values. I'm going to go ahead and draw that table of values down here. We are going to place this locator point or vertex in the middle down here. So this would be negative 2 and 8. So we can go ahead and complete the x values. We can go down to, or we can go up to negative 1 and then 0, and then go down to negative 3, negative 4. So we go ahead and determine the values of y for these 4 blanks here. So we're going to start with x is equal to negative 1. So I'm going to go ahead and show that work up here. So this is for x equals negative 1. Again, what to do is we plug this negative 1 into the x and we solve for the y. And so this would come out. And so we're going to put in the negative 1 for the x. And so this would come out negative 3. Negative 1 plus 2 is positive 1. And then that is plus 8. The absolute value of positive 1 is positive 1. So that would be negative 3 times 1 plus 8. So this comes out negative 3 plus 8 is positive 5. So this value right here is positive 5. Now I'm going to show the work when x is negative 3 on the side here. Okay, please notice that in this work right here, we have a negative 3 plus 2 is negative 1. Absolute value of negative 1 is positive 1, and that's how we got a negative 3 here, because we multiply that to negative 3, and negative 3 plus 8 is positive 5. So we can go ahead and write that positive 5 right here. And so I'm going to go ahead and show the work for y when x is 0 and y when x is negative 4 at the bottom down here. So we have completed the table of values right here, and this is the work for this numbers that we got and how we got these. So the next step is to sketch the graph of this equation. So we're going to start with a vertex. You can start anywhere. So that would be a -2 and 8. So -2, we go up to 8. So this is our vertex up here. Then we have a -1 goes to 5. So this is where it's going to sit. And then we have a 0 goes to 2. So this is the next dot right there. And then we have -3. So -3 is up here. And then it's going to go to 5. So it's going to go up here. And the -4 goes to 2. So this is the next dot. So I'm going to go ahead and sketch the graph of this equation. So this is the graph of this equation that we have right here. Now, please notice that the left tail of this graph is going to go towards the -infinity on the x-axis. And this one is going to go to the +infinity on the positive x-axis. And so we go ahead and say that the domain for this graph would be all real numbers. But for the range, here are the values of y starting from 8 going down. So I go ahead and write that information up here. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!